Okay, hello everyone. Welcome to the meeting of the 6LO working group. Please make sure that you are in the right room. My name is Carlos Gomez. The other chair is Shweta Bandari. She is online today. We have our responsible AD, Eric Klein, here. And we have at least 1 minute taker. Dominique volunteered once again as minute taker for 6LO. So thank you so much for your continued support. And we encourage actually everyone to join the collaborative process of taking minutes, which will be done as usual by means of Hedgedoc. You can find the pointer at the end of the slide. Also, we might need some Jabber or Zulip scribe. Is there anyone who would like to volunteer? If not, then we'll see if we can handle that by ourselves. And finally, on the screen, you can also find the link to the online agenda, which anyway you have probably seen many times already. So there are a few tips for this meeting, similar to the last couple of meetings, which had an in-person component. For in-person participants, please make sure that you sign into the session, into the Meet Echo session, for example, by using the on-site tool, which you can find from the data tracker agenda. It's also available from QR codes here. Recall that we are going to use Meet Echo to manage the queue. So there's a single unified queue, which is the one in Meet Echo. Also for remote participants, well, you just need to keep your audio and video off unless you are presenting something. Then this is the note well. This is a reminder of IETF policies on several important topics, such as patents, code of conduct, a few others. So please make sure that you have read it. And this is the agenda proposed for today. So the first presentation is the usual chair's introduction, which is currently in progress. This will be followed by an update of the IPv6 over NFC draft given by Yongwang Choi. Next, there will be an update of the 6LO use cases draft by Yonggyun Hong. And that will be followed by a couple of presentations related with neighbor discovery. The first one is multicast address listener registration. And the second one is a new draft, although the idea had been presented in a previous IETF, which is on prefix registration. Both will be given by Pascal. Then there will be another set of two presentations. You may recall that in August, we had a call for working group adoption on the document that was known as Native Short Address, NSA. So there was a lot of discussion then, and the authors have updated the documents, and now they have been renamed as Path-Aware Semantic Addressing, PASA. So there will be a presentation on the base draft and also the companion reliability considerations draft, both presentations given by Luigi. Then I will present the update of the draft on transmission of SHIC complex packets over 15.4 networks. And as you can see, this leads already to the total allocated time for this session, which is 90 minutes. So you can see that this is a pretty packed agenda. So we need to kindly request the presenters to try to stick to the allocated times, which in addition should allow for some time for discussion and questions and so on. Nevertheless, if time permits, we have another presentation, which is entitled IP Payload Compression Excluding Transport Layer by Hangxi. So is there any comment, any question on the agenda? Okay, if there is none, let's proceed to the status report on the working group documents. We have currently 4 working group documents in 6LO. The first one is IPv6 over PLC, which is currently in the RFC editor queue. The second document is IPv6 over NFC. You may recall that this draft was evaluated some time ago by the ISG, then it was modified, and now after some time, the draft has been updated, and also we have interesting news that the draft is back in ISG evaluation state, and it is actually scheduled for the telechat agenda in December. So it will be interesting to see the feedback from the ISG, and there will be a presentation on the last update later today. The third document is the 6 law use cases draft, which had been evaluated by a couple of directorates. Then the draft has been updated, trying to address the remaining comments. And the document has also entered the ISG evaluation state, and it's actually on the same telechat agenda on the same day in December. This will also be presented later today. And the last working group document is the multicast address listener registration draft, which has been updated several times since the last IETF, and it is perhaps getting close to being ready for working group last call. So, is there any comment or question? If not, then let's proceed to the first or the next presentation, which is on IPv6 over NFC.
Thank you, This is Youngwon Choi from Entry Korea. I'm going to present uh, the status update of the IPv6 over NFC. This version is number 18. Next slide, please. The first page is the quick introduction about the NFC. Actually, every time I show that the introduction. The next slide, please. And this is the history of the draft. The draft has such a long history, actually. I think the longest history ever in IETF, I think. The first telechat 2 years ago, just we got the updated two draft version, the number 17. After that, there is something comment from the Eric. He wanted to know the changes because there's new release of the data link of NFC is version number 1.4 from the 1.3. So he wants to know the changes between the specifications. So, and then after that, finally I got the good news from the Eric with the draft update with the new schedule of the telechat. And we are going to a second round of chat on December. Next slide, please. This is current status. Next slide, please. So since the previous meeting result, actually, Eric gave us the comment, gave me the comment. Actually, he got the finally reviewed about the two specification of the data link of NFC version 1.3 and 1.4. But I think he do not have any more concern about that, the changes about the two between the two specifications. And then he gave me the one comment from about the security consideration revision about that in comparison with the other 604 document. And then a couple of days ago, he also gave me mentioned about the RFC 3756 about the sub-IP layer security consideration for IPv6. He gave me that I think we need to put the new references of the RFC 3756. So I will produce the new draft version, maybe 19, as soon as we finish that the 6.0 session this time. Next slide, please. So this is the details of the changes from the version 17 to 80. Actually, I gave some explanation about that. The first graph about that, the LLCP, this is the data link of the NFC version number 1.4 is about that security data transfer of LLCP. And the second paragraph is actually this kind of the short address, the secret consideration about the short address of the NFC. Next slide, please. So next step, actually, uh, I'm going to produce the revision, the version 19. I put that, I mentioned that the RFC 3756 will be there, put, and then we will have the second round of telechat on December 15th. So I can see that the final step, finally, and then I can see that the end of the little bit more than before, I think. Thank you. Any comment? Question or comment?
Any questions or comments in the room or remotely? Okay, so if there are none, thank you for the presentation. It will be interesting to see the feedback from the ISG, hopefully in just a few weeks. So the next presentation is the 6LO use cases draft.
Can I take off my mask? Okay. Good afternoon, everyone. My name is Yonggun Hong. I'll present the 6-row use case draft. Next page, please. Yeah, this is the history and status. This is the 14 revision. So in this year, the February, this document moved to ISC evaluation. So we are waiting some the feedback. Next page. Yes, this is the update after last meeting. We got a couple of comments. So we believe that we resolved comment, but among the comment from the robot Spark, there are some the comment was not remaining as unresolved. That is the handling appendix A and the security control section. So appendix A is neither introduced or refers from the body of this document. So he asked why it is here. Yes, he's right. So in the revision, we try to resolve his comment. And the second thing is the security control section. Robert Spark says that he didn't satisfy our update. So in this revision, we also try to resolve his comment. Next page. Yeah, the first thing is to Appendix A. The Appendix A is a design space dimension for 6-row deployment. So in old version of this draft, this content in Appendix A is located in main body, but during the progressing this draft and the resolving some document, it was moved to Appendix A. Also, there are comments to keep the Appendix A because it provides useful information for 6-row deployment. So our resolution is to add a related sentence in the introduction section. So it is a simple modification. Next, please. Yeah, the second thing is to security control section. It was come from the robot Spark. So before the text is like this, it is a little short, but he suggests to add some sentence which is related to L2 layer security. So we analyze other 6-row RFC document. So we got some ideas from the existing 6-row RFC document. So we modify the security control section as like this. So in the last week, I replied to Robert Spark for how about changing this update. But until now, we don't have any feedback yet. We hope so. It resolved his comment. Okay, next page, please. Yes, that's all. Okay, thank you. Any question or comment?
Any comments, questions? So it seems we have none. This is also another document that is on the telechat agenda for December. So it will be interesting to see also the feedback from the ISG on this document.
Thank you.
Thank you very much. So the next couple of presentations will be given by Pascal on the two drafts related with IPv6 ND.
Hello, did you have a, no? No, I will. Okay. So this is Pascal from Cisco. Um, this document here is an extension of RFC 8505 that aims at registering not only unicast address as we do in 8505, but also multicast and anycast addresses. It comes from a requirement that was made by the WISON Alliance. So for those who are not aware of the WISON Alliance, WISON develops a standard for smart grid devices, which operates on the 802.15.4 sub-gig ISM band. So that allows several kilometers between devices. And the devices are deployed in mesh networks, which can range from hundreds to thousands of nodes. Those nodes join the network using 6LoWPAN-ND, and then REPL is used to route inside the subnet. So each mesh is a single /64, where you can find those thousands of nodes, and the links are about 100 kbps speed. So it's all route over using REPL. Now, the reason why we developed 6LoWPAN-ND the way we did was to avoid multicast, because the 6LoWPAN devices are usually sleeping, so they cannot respond to lookups. And we cannot afford basically the energy of broadcasting all the time. So the WISON Alliance recognized that, but at the same time they said, hey, we also have multicast traffic. And the benefits we see for 6LoWPAN-ND for unicast, we want those same benefits for multicast. And so when they looked at MLD, they said, well, that won't float the boat. We need something where the device can sleep exactly the same way as it would for unicast. And so we turned the MLD model, where the router polls the devices and the devices have to be awake, into just for 8505, same thing, as a model where the device wakes up, makes a request to the router, and can go back to sleep. For those who are aware of RFC 9010, RFC 9010 allows to redistribute the host addresses, which are learned from 8505, into REPL. So these are called external routes, but REPL allows for unique for address and prefix external routes. REPL also allows for multicast addresses and anycast addresses. So what we do in this draft is not only enable the registration of anycast and multicast addresses in 8505, we also couple that with work on the REPL side to redistribute this knowledge into REPL. Same as 8505, the advertisement is unaware and abstract, agnostic to the routing that happens on the other side of the router. So the day we want to use this for any other multicast routing protocol like PIM, we can always do that. So this makes it so that the 6LoWPAN-ND family is growing. We have this multicast registration, which, as you said, is close to finish. We are done with this document pretty much. We have the unicast lookup, which has not progressed for a long time. We've not been working on it. We'll have to decide what we do with it. But basically, the idea is, since the routing fabric knows where the addresses are, why do we still broadcast lookups? So can we generalize what we do so we don't even have broadcasts for lookups? And then there is the new member of the family, which I will discuss after, which is the prefix registration. So this gives us kind of an interesting family now. Next slide, please. So what changes do we see? So as you said, Carlos, we've moved quite a bit since last IETF. So we have improved the terminology. We have beefed up the section that says how we improve REPL, how we extend REPL. The 6LoWPAN piece itself has been rather stable, but on the REPL side, we have improved, in particular, the way we look at freshness. For those who are aware of the way REPL works, there is a sequence counter that comes from the host when the host moves. which is passed through 8505 and then redistributed into REPO as a sequence count or the path sequence that allows to find which is the most fresh, the freshest path, and kill the older path. Well, when you inject a multicast address from multiple members, those numbers may not compare, because each host will, or each router will maintain its own sequence number. So as long as it's unicast, it's okay, there is a single one. But if it's multicast, then there can be multiple sources and the numbers cannot compare. So we explain how we use the rover field, which is taken from 6LO-ND and injected into REPO as a proof of ownership of what's being distributed. We basically say, hey, if it's coming from the same guy, so same rover, then you can compare the sequence number and eliminate the stale routes. If it's coming from different rovers, so it's different listeners for the same multicast address, then effectively all the routes have to be injected in the multicast routing table. Another thing that happens is the introduction of the P field, but I will go back to that on the next slide. And with clarifying the language, when it's anycast or multicast, we are using the term subscribe as opposed to register. Just to say, hey, it's a subscription because you intend to get a multicast packet delivered, basically. We discussed last time an issue about the consistent uptime option. So the consistent uptime function is option is the way the host can figure if the router has lost a registration state. Basically, did the router reboot, for instance, since last time this device registered, in which case the device needs to re-register because the router may have lost the state. This impacts 6-man. And so the question was, and it's still, and I guess Eric will tell us, basically what we do with this consistent option, uptime option. And then again, there is a next slide, so you'll be free to. Next slide, please. So yes, there is the option. It has changed a little bit because we want to exchange the state sequence information in both directions, so the host can know what is the most recent state for the router and reciprocally. It's completely abstract to the fact that we use it for 6LO-ND or any other state for which the host and the router must have some kind of agreement. Right now, it is still in this spec because we didn't get a clear message that we need to write a different spec for it. I'm perfectly happy with that. And as far as I know, we can go for workgroup last call in that state. And Eric, you jump in when you want. Even if during the workgroup last call we decide to take it off, I don't see why that should hold the workgroup last call, because taking off that section is still good reviews. I mean, even if we get reviews during workgroup last call for this and we take it off, the reviews are still good to take. No.
Yeah, do you have a problem with the mic?
There we go. Does that work? Yes. Yeah, this fell off through the cracks a little bit from the last Philadelphia meeting. I did send email to 6-man chairs, and there was but I failed to follow up, and I think there was no general discussion on that email thread that I said. So I think a perfectly fine thing to do is to do an, if you want to do an adoption call, do an adoption call, and I'll CC 6-man.
It's workgroup last call.
Yeah, last call, sorry, and I'll CC 6-man, and we'll talk about it then.
I mean, like we said, any review is good to take, even if we take that section off later.
Sure.
So I don't see that as blocking workgroup last call. Next slide, please.
Yes.
So the other change doesn't affect the binary of the packets that would be thrown. It's just that since we are doing the work on the prefix registration for a number of reasons, we needed yet another flag to indicate prefix. But if you look at it, unicast, multicast, anycast, and prefix are mutually exclusive. So why take yet another bit saying it's mutually exclusive with the others? So the idea was, let's keep the 2 bits with the same value, 0 unicast, 1 multicast, 0, well, second bit on any cast, but call that a single field. So the value 3 would be available to us for the prefix registration. So it doesn't change the implementation for this draft, but it allows to free and to give a sense to what this means when both multicast and anycast bits are set. Basically, it will mean prefix. By the way, so the prefix is the second draft I will be talking about right after. But remember, for those who have a pending draft, there is this early IANA discussion that has happened for those drafts. And Amanda came to me and said, what do I do with this thing? And well, that's a question to the group. If we agree to do the prefix with the value 3, then we could avoid having to declare a registry for this draft for which the last available value 3 would be assigned by the draft which is right coming up. On the other hand, if we delay the work on the prefix or we don't go for adoption, etc., then we probably want to have this registry so the value 3 remains unassigned. So at the moment, the assumption is we don't know what we do with the other draft. So this draft has a IANA section which requires a registry for this with the value 3 unassigned. That's the state of the art. If anybody jumps to the mic, I'll be happy. Next slide, please. So yes, I mean, no news from 6man, and certainly it would be nice at least to circulate this at 6man during the workgroup last call, and ready to start the workgroup last call as far as I'm concerned.
Yes, so the idea will be to start the working group last call. Perhaps we might need to keep 6man maybe in the loop somehow. Eric? Yeah. Yes.
It kind of fits with what Bob said at 6man the other day, which is like when the group is, is happy that this thing is needed, then we can circulate by them, but not too early, but that's not too early anymore.
Okay. So then, well, I don't know if there are other comments or questions about this first presentation.
Just a gentle reminder that Wysan is effectively waiting for the RFC for their own specs. So, I mean, if we can be swift on that one, that would be nice.
Sure. Okay, so then let's proceed to the second presentation.
Okay, so this is the newest and bestest member of the family. So, next slide, please. So this one we already saw. Next slide. Yeah. We are already redistributing what we learned from 8505 into routing. This is not a surprise. The way it works is today when a host or even a router has a unicast address and he wants to ensure there is reachability back independently of what the routing is above the first hop router, it will set the R flag in 8505 telling the router, hey, whatever you're doing in dproxy, Rift, EVPN, you name it, repo, obviously, do whatever is necessary for me because I won't be doing it myself. On the other hand, if it's a repo router doing it, then it will not set the R flag because it will inject its own DAO messages. So it doesn't need the other router to do it. With 9010, if the bit is set, then the repo router that accepts the registration sends a DAO message with the external bit set, meaning this is a route to the outside. Next slide. So this is what we have here. And well, that's effectively the way Ripple works. So you can see this prefix A, which is the whole Wysan network, if you like, the single subnet. And you can see that Mr. C and Mr. D tell the root that their parent is B, and the root will know that it has this last hop to make to reach. Basically, you see on the right routing table that's built out of that. Next slide. Okay, so this is 9010. The difference is now the hop between C and this node L that you can see, this LFN as we call it in Wysan. This device is effectively injected into REPL by C as opposed to L, okay, as an external route. The result is pretty much the same. It's just that the router is aware that this host does not belong to REPL, so it cannot be expected to terminate the REPL artifacts that we place in the packet. So typically a tunnel from the route that is supposed to reach L will terminate at C. That's pretty much the main difference with the usual. Usually the tunnel will terminate at the node because it's REPL aware. But here we don't even expect that the node L is capable of terminating the tunnel, so we terminate it at C. Now we have this for hosts, but next slide, please. We don't have it for prefix. So what are we waiting for? There are a number of reasons why we would do it for prefix. Not any type of prefix. We never wanted and still don't want REPL to become a transit network because we expect still this to be a very edge network. But for this edge node that we saw, there could still be an external stub network connected. Or it could be that this edge node is not only owner of one address, but it could be owner of a prefix. For instance, there is this story of doing /64 per host, which is perfectly good and legal. Why would not REPL allow for it? So if we go for something like that, we have the need to expose to the REPL router that we have ownership of not just one address, but a full prefix. And that's what we are doing here. Next slide, please. So this is a reminder as before that REPL is not only for host addresses and host routes. REPL is a generic distance vector protocol, which is optimized for a number of reasons for power, but still it can route prefixes just like it can route host routes. And basically these are the kind of routing table that you build. Next slide. And what we're missing is the pendant of the other drawing where effectively the host as a routing protocol independent, agnostic way of telling the router, hey, I have this stub attached to me or this stub that I own. And so this is the gap that this draft is attempting to solve. So basically, in this case, it will be a REPL again, but it could be any routing protocol or any action. And I will be presenting this draft at Slack tomorrow. Because it solves the Slack prime just like it helps in the REPL case. Slack. Well, too much Slack these days. So Snack. So I will skip that, but just as an example of how that addresses the Snack use cases. Basically, as soon as a router advertised, like a stub router advertises to a main router that it has a prefix, the main router can forward the packets to that first router. You don't need a full-fledged routing protocol with distances and stuff because the stub is attached to 6LR2. So why go and participate to a BGP or an OSPF of this world when all you're trying to say is, hey, I have this prefix, it's attached to me, you can give me the packet, it's going to be loopless. Okay, so that's effectively what you're doing. Next slide. And a symmetrical case is when the stubs are separate from the main link. That can be typical of some households, I guess, when you have levels and stuff. Same thing, the routers which handle the stubs can declare to the main router, hey, I have this stub, and now you get reachability back. Next slide. So the interesting piece is, okay, now we are doing 8505 for prefixes. What becomes of that? Do you want to do auto configuration? And that's an interesting one, because we could. And we have to work on it. We have to decide what we do, but we could. Say that we've got this /48 for your home. Could you say, oh, routers are free to autoconf /64 inside that /48? Because we have still this 6LBR, which could manage, you can do it, it's a duplicate, or you can't do it. I mean, we have all the tools that would basically say, hey, you have this prefix or you can't have this prefix. So it's pretty cool by reusing what we have, but instead of looking at exact match of, okay, dad, this address already owned, exact match with this other address. Now we could look at, is this prefix part of that other prefix? Is this other prefix available for autoconfig subnets of it? Okay, so there is a whole possibility there that we could develop just because we have that anyway. And it would be an extension of what we do for that, but by looking at which prefix is inside which other prefix. So the draft doesn't do auto allocation or prefix allocation right now, but that's a possibility that is offered to us with this draft. Next slide. So, well, how would that work? Well, pretty much the same way as 9010 works. I mean, the stub router advertises through ND the one-hop reachability of the prefix. And then the routers above will do whatever is necessary. Maybe they aggregate, maybe they redistribute, whatever they have to do in their own routing protocol. And here I have the case of EVPN, but it could be anything. Basically, they will inject, if the R flag is set, same R flag as 8505. If it's set, then instead of injecting a host route, they will inject a prefix route. Now, there is a question. I presented that slide 2 IETFs ago, because when we started this, I presented it before I wrote the draft to see if there was interest. The group kind of told me, hey, yes, we are interested in working on that. So I produced the draft. And in my slides, I indicated it could have been an RS, and the arrow option could have become a stub router or option or something. The names are not that important. It could be cool to figure out if we want to use RS or NS. At the moment, to keep it very similar to 8505, it's an arrow option in an NS, and there is just a prefix length that's added to the arrow option. But if you guys think it's more relevant to call it an RS, then it could become an RS. Whatever works for me. Next slide. And big surprise, as I introduced those 2 bits, which can say unicast, multicast, anycast. Now, the proposal is to assign value 11 to say, hey, we are registering for a prefix. And if we are registering for a prefix, yes, you have a prefix length somewhere in this packet. Next slide. So in the arrow, effectively. And this is not changed much. This just shows that same as 8505 with 8928. 8928 is the way we do sound in that world. That basically says, hey, when you register an address, if this route ownership verifier is a crypto ID, then you can be challenged for owning it. So if the same address shows up somewhere else, the routers will challenge the somewhere else to see if this token can be validated. If the host can validate the token, it means he has the private address that goes with it, blah, blah. So he can own the address. That's basically the way we avoid stealing addresses. Well, we can do the exact same thing for prefixes. If the prefixes are owned by a single node, or if the different owners share the same key, then it's possible to ensure that a route can only be injected in the routing fabric by the real owners. Okay, so the same zero trust capabilities we have for host now becomes available for prefixes as well. Next slide. And this is just a trick on how this could be used effectively for IPv4 prefixes by putting them inside /96. Same thing, you would provision a certain prefix and then /96 and encapsulate the 10 dot or whatever for a certain tenant. So this is more of a data center type of use case, like Lisp or IVPN. Next slide. Okay, so it's just a beginning. There are tons of things we could do. Would we want to add, to make it an RS, make it an NS? Would we like to extend the proof of ownership per IFC 8928, which is not done yet in this draft? More interesting, since we are advertising prefixes and we may advertise them through different places, do we want to influence load balancing? Again, that's more of a data center type of use case. And then again, it's not a distance we're talking about, right? We are talking about weights. we are not doing a routing protocol. We are still in NS space. But in NS, you have a preferred router. You have this router preference thing, right? Same thing when we inject a prefix, we could say, hey, if I have several parents to whom I want to advertise this prefix, I could say, I want more traffic through this parent than through that one, for instance, because I don't know. I mean, that's the way balance mailings. And well, that's pretty much it. I just want to be very explicit that this is a beginning and there is a lot of power that we could develop with this idea. So don't take for granted the fact that it's an NS or that the capabilities that are disclosed in 0.0 are very limited. There are tons of things we could be doing. But then again, it's not a routing protocol. It's just advertise the one-hop reachability to a stub. And that's pretty much it. So yes, I would like to see discussions on where we want to go with this. I mean, if we go for adoption, would we care for doing an SRS? Do we want to call the ERO with P equals 3 a stub registration option? Do we want to support IPv4 prefixes using /96? Do we want to extend the zero trust that we have with 8928? And all those questions. And that's pretty much it for me.
Okay, thank you, Pascal. So are there any comments or questions?
And I was encouraged last time, I mean, 2 IETFs ago, to do this work. Are you still kind of supportive of this, seeing this happen? Yeah, okay, I like that.
Yeah, so now since there is a written draft, now it's a good moment to actually read it and provide feedback. So we encourage the working group to read the document and provide comments. Thank you. So then the next set of presentations will be the ones related with path-aware semantic addressing.
I'm requesting to share, so please follow the
I'm granting you.
Okay. So I'm Luigi. I'm going to give you an update on what was named before NSA, the native short addressing, which is now called path-aware semantic addressing. It's more meaningful as a name and more focused on the real content, the real aim of this work. This is a bit the history, how the draft is advancing. We are back again to 0.0 because we changed the name. Okay, we have, beside the name, we have to welcome 2 more co-authors. One is Pascal, that did a great job in helping us. We'll go over his contribution, Kieran as well. All this contribution actually came up from the nice discussion that we had during the working group call for adoption. That I mean, the document didn't make through, but actually, all in all, we did good progress, to be honest. So that's wonderful from my perspective. The outcome of the call for adoption was the fact that we need some clarification. Sorry, the chairs did a good summary of all this discussion that we had on the mailing list. Was quite a long discussion. I think in the last year or so was the longest, if I dare to say. But
69 emails.
yeah, it was pretty good, I would say. So, and as I said before, Kieran was suggesting a new use case, and we had discussion on that. And also, Pascal, in one of the latest email, was suggesting to use the routing header as a way to move forward, okay, and go over what we the different points that were discussed, right? So, yeah, the main changes beyond the name in the document is the fact that we have now an extensive use case section, which better explains where we see this solution to apply, because it's not should not be considered a general solution that you can use in all the possible 6-law scenarios. Okay, there are specific scenarios that where it is very reasonable to be used. Okay, and we have a tighter connection with the 6-law use cases draft. And then there is the new header format. So the use of the 6-law routing header in order to encapsulate the packet. And this is very, very meaningful because it's more in line with the general solution that are designed in this group, right? Want to point out that actually the allocation function, which just to recall you, is the way we assign addresses in the topology. And at the end, the forwarding algorithm, so the way you decide where to send the packet, that piece of work remains unchanged. That is pretty stable. It's just the way where we use it, in which use cases, and actually how we encode our packets. Okay. As I said, we try to have to type better the work with the 6-law use cases. This is one of the points that the chairs put in the summary email closing the call for adoption, the clarification of whether we should use this. The main use case is obviously related to PLC, where we have already 3 topologies, which is also the logical topology that PASA, ex-NSA, tried to build in order to forward the packets. And obviously, if you do this stateless approach in order to forward, you are sensible to mobility. So I mean, PLC, there are no mobility requirements. There are other scenarios where the mobility is not a requirement, but then you have to build the tree topology, which may or may not fit. We can claim the star topology is kind of a tree, but it's a discussion for another talk. So I forgot to put the animation here. Actually, the idea was to give you in one slide a snapshot of the 4 main use cases that we detailed in the document, basically the smart grid, smart home, data center monitoring. And when we say monitoring, is not about the data traffic itself, it's monitoring of the electrical appliances itself is a different thing. So it basically is based on PLC again. Where we can use PASA, and the use case that Kiran added about the industrial operation technology networks, which is let's say they're based on different layer 2 technology from which you cannot necessarily natively adapt all the full 6-law protocol stack, but you can have a software update that allows you to have stateless forwarding. And yeah, again, this PASA solution seems to fit well. Okay. I invite you to really go over the use cases and see if this solves all the clarification requested that we received in an email and also suggested by the chairs. So as for the encapsulation format itself, what we have is now to use the 6-law routing header as suggested, as defined in RFC 8138. So we will have page 1, this routing header, and then the normal low-pan IPHC, so basically the IPv6 compressed header according to 6282. Okay, no special treatment there. What we do is actually once you build what we call the PASA RH header is, well, the format is pretty simple. You have the type that allows you to understand which kind of routing header you are using. Then we have 2 bits that allows us to understand what kind of address you have in this header, the size of the address, and then we have a set of quads. Quads are just 2 octets. It's a couple of octets. Like we cut the IPv6 addresses with the columns, right? So the idea is basically when we add this header, we take the destination address from the IPHC and put it there. And you don't need to put it in the IPHC. You can delete it at once so that you don't need to have duplicate. And then each and every node, what does, it looks at this header and it takes the forwarding decision according to the rules that were already there now. And this piece of content that update is something we discussed at length by email with Pascal. I thank you again for the idea and the help that he put and the effort that put in this document. So basically, how these things all works together. The parser domain just does compress and compress the packets according to the specification in this document. The prefix of the parser domain represent the context that we use to compress according to 6282. So basically, you can shrink the big IPv6 address at least to a slash to only 64 bits. Okay, according to the size of the parser address, you can do even more if you wish. On the way back, the document describes how to take the parser address and rebuild the full IPv6 address, just a coalitions operation that is also already described in 8138. Okay, so when we send a packet, we compress according to 6282, okay, based on the context. And then, as I said, we take the destination address, we put it in the RH, we lead it from IPHC, and we set the size accordingly, etc., and we send the packet. The receiving side, what we do is basically we take the address in the RH header, and we use it as a IID, and we can rebuild the full IPv6 address according to 8138. There is nothing really special. And this is the intra-domain communication in a parser domain, okay? From for external communication, things are a little bit different because we need to send outside. So this is something that I wouldn't say we're still working on. We have to better define inside the document, and we are discussing again with Pascal. But the idea is pretty simple. If we have to send outside, what we need to do is just send up to the root, nothing more, right? And when we receive something from the outside, the root will create the RH header with the parser address, and this becomes a intra-domain communication and will be delivered to the hopefully to the right destination. Okay. So all in all, this is the updates on this specific piece of work with different names. So if you have any question or comments on this.
Okay, so there's two people in the queue. Yonggeun.
Okay, thank you for your good presentation, and thank you for your report, the 6-row use case draft. I think that the 6-row use case draft is a kind of the information to other document, so it is very good. So I'm wondering, so you report the PLC cases, the PLC can be utilized in G3 PLC or electricity usage. So I'm wondering, your idea is there any practical reference site to use, or do you have any plan to utilize your this content?
Can you repeat the question? I didn't get it. I apologize. What is exactly the point with PLC?
Yes, in the 6-row use case draft, the PLC is used for G3 PLC or electricity. It is the practical site.
Mm-hmm.
Yeah. So you're the PSSA. Do you have any reference site, or do you have any plan to utilize your idea?
Not specifically. I mean, no. we need to look in more details to use that.
Okay. Thank
But yeah, good point. Thank you. Thank you for bringing this up.
Hi, Tommaso Pecorella from University of Florence. Just a couple of quick questions, or better, quick note. I wouldn't rule out, or I would ask you to state in the document why you did rule out other kind of heater compression other than IPHC, for example, GHC or SHIC. I know that probably for the document it is more important to explain how for IPHC is working the address expansion and compression, but there are other methods as well. And the second is a suggestion for addresses that are going outside of the network. I found myself very comfortable with stateful compression for IPHC that sure enough it requires also to have a distribution for the contexts, but it's very useful. Just because your scenario seems to be just fitting the idea that the outside addresses or better, the addresses toward the internet are just a handful.
Yeah, that's true. But I agree on the second comments that you did about the external communication. About the first part, the first comment that you said, are we ruling out something? Let's say that we did not include this something in this document. But this is my personal point of view. This is something to discuss also with the other co-authors and with you guys, the working group. But we don't necessarily rule out other form of compressions. We maybe need other specification at that side.
Yeah.
It's
Thank
not
you. It was just a point that in this case, good, but you would have to state that the IPHC is an example.
I see.
Just editorial, of course.
Okay. But yeah, I do agree. I do agree. In a certain way, it comes also to in the document from the original one. Let's say there was also some kind of optimization in the way you treat the addresses that are external. And as I just said, is an optimization we don't need in the basic specification. It's something we can add optionally if we wish, and the group is interested. But the basic set of specification that we are converging on looks okay. But thanks.
Hello, Esko Dijk here. Yeah, I was looking at one of the use cases that you introduced. So that's a smart home use case, and again about the PLC there. So yeah, what I was thinking, if you look at that topology, then typically in the smart home, there's also something like well, what we call sometimes infrastructure link. So that's like a Wi-Fi or Ethernet link that binds everything together. So that, yeah, that I suppose we have that there, and then there are a number of PLC gateways, and those you can consider as a stub network. So what Pascal introduced. And actually, it looks to me like each PLC network is kind of a flat network. There's one power line connecting all the devices. So I don't really see the need for, well, some kind of hierarchical addressing. So
yeah, that's not true actually, because in the different use cases, and we have ASCII art in the document that tries to explain what there is also in the text, is the fact that at the end of the day, you have some hierarchy in your PLC network. We have, because one thing is the end device, which could be something big or something small, but all the connecting infrastructure, as small as a smart home, might have some hierarchy. Limited. You don't have 3,000 levels, but there is not necessarily completely flat.
okay, so you mean that?
But if you could have a look to the use cases section and send us all the feedback that you have, that would be great.
Yeah, I think, okay, then it's good maybe to update the picture also. So if the PLC has some hierarchy, then I can understand maybe better yeah, how that fits. But overall, the use case doesn't look like the smart home that's now usually introduced today, where lots of devices are wireless, like your lights and doorbell.
Yeah,
all
that's
are on
true.
wireless networks today. So,
Excellent point. And this is
yeah.
related to the next presentation because
Okay.
one thing that you have in this solution is the reliability aspects. Because if you have this stateless forwarding, is based on the knowledge of your neighborhood. But if something goes wrong and you don't have a routing protocol that allows you to go around, then you need to manage the reliability in a different way. So what I want to say by that is that this work, in principle, could work in the wireless environment, but there is a reliability issue that you have to look at it carefully because the wireless link is not as stable as a PLC wired link. So,
Yeah, so in wireless,
this comes also to the
Okay.
initial comments that I made. This solution is not to replace Ripple, for example, and be used to as a general solution. There are cases that you can use it, okay? Cases that's meaningful. It's not.
okay, yeah, I'm just doubting a bit on home use case. That's all. But okay, I will check it. Thanks.
But please, again, read the section and send us all your doubts. That would be good input anyway.
Oh, sorry, I was going to remove Esco from the queue, but I accidentally removed Wenpeng as well. So Wenpeng, if you still want to make a comment.
Yes, quick comment. Guangpeng from Huawei, one of the authors. As many knew that we had a good discussion on last call for adoption for the NSA document, but for the PASA, I suggest many people who interested in this document can send their concerns in the mailing list. Thanks.
Okay, so yeah, if there are no other comments, then I guess we can proceed to the next companion document, which is on the reliability considerations.
Okay, this is an update on what was before called the NSA reliability. Now, truth to be said, the new version of the draft is more a renaming update. But since we did not have the possibility to present this document last time, we will go over it this time. Certainly, let's say this is an initial effort and might have some adjustments to be done, but the more important point is to receive your feedback. So I hope that at some point we will have the possibility to discuss this on the mailing list. Okay, so new document submitted in October. As I said, the main change is the naming. We try to go over the whole document to replace NSA bypass and few other changes were the meaningful. But we will work more on this document for 116. Okay, so the main content is pretty simple. We have a general introduction to the problem, the possible solution classes, which are pretty much two, and I will present in the rest of this presentation. There is also a section about consideration how to detect the failure and the recovery as well, because this is also a change in topology. It's not about only walk around something that is missing, is also understanding when this link, for example, or node that was not available is coming back, and we can go back to the initial state. And then some consideration about the robustness. Yeah. So obviously, in order to have reliability, the prerequisite is to have redundant links. If you don't have an alternative, if something breaks, it breaks, and you lose connectivity. So this is obviously what you need at the beginning. Um, doesn't mean that you need these redundant links all to be active at the same time. So it could be an active passive kind of usage. Okay. But the point is that when you use the active links, you must be able to build a tree, because Pasa relies on this logical tree topology. Okay. And the other thing is what we need is to have a secondary parent. So each node needs two parents. Okay. Which is pretty natural, so that we can alternate and have reliability. This is except the root node, in the sense that the root node is the one that is the gateway to the internet, and starting from there, you have different kind of reliabilities, and you are outside the PASA domain. So yeah, that's a different story. And the alternative parent could be is connected through a non-active link. Now, when you have this set of conditions that hold, then you have basically two choices. Either you use multiple addresses, which basically boils down to have a different topology. Okay, so it's like multi-topology routing. So basically you have two parallel instances of a tree topology that not match, in the sense that, so that when one link is down, you have an alternative path on the other topology, right? Or you can use one single address, or like we do in the normal case, but then you need to store some addresses in order to know which is your alternative parent or children. Okay, in a multi-topology case, you don't need that. They are really running in parallel. So, but in a certain way, both require some additional state on the different nodes. So I think this is pretty trivial. I mean, there is not such a thing as a free lunch, right? So when the multi-address case, in case of a link, you will have basically two routes, and then you have these multiple links. You build a parallel topology. When something happens, like in this case, in this example, we have the link between 100 and 10 that at some point breaks. After detection, 100 can use the other topology in order to send an ICMP notification to the root in order to say, this link is down. And this is done on the alternative topology using the address 01100, sorry for all these bits, going through the alternative route and then the original route, okay? This is from, let's say, from the bottom side of the link. On the upstream side, the node 10 just send an ICMP straight up through the different layers to the root. And for optimization, you can use some ICMP messages also to the different children. In this way, whenever there is a packet coming from the leaves or the subtrees of 100 going up, and in principle should go through the link between 100 and 10, you can tunnel through the alternative topology and send it to the root. Okay? On the way back, let's say that there is a packet from the root, could come externally or from the local domain, doesn't matter. When it is on the root and you look at the destination address, now the root needs to remember that there is a broken link, and so that it needs to tunnel the packet on the alternative topology back to 100. Okay? So basically, it uses the alternative path, goes to 100, decapsulate, you see the real destination, and you send it down to the real destination. Okay? So the state that you need to add is in each node that has a broken link upstream or downstream, there is this additional state that you have to remember that the link is broken, but it's not that much state. You still need to have this information on the node, right? You need to know the alternative path, but this is pretty simple because you have the secondary topology. Okay, you just need to encapsulate. There is some state on the root because the root has to have the knowledge of all ongoing failures and where to encapsulate in order to tunnel the packet to the right node. I mean, now this is hopefully limited state because you have few failures, but if you have a lot of failures popping up in your network, so the state that you have to keep on the root is not anymore your problem. You have a bigger issue with the reliability, physical reliability of your network, right?
So if I may, if you think it's possible to speed up a little bit.
Yes, yes. So I described this logic though, so I don't really need to go over this slide. Here. I will go straight to the single address case with the same scenario. Okay, a link failure between 10 and 100. As you can see, now we don't have double addressing. It's just that in this case, we need to keep a bigger neighbor state with alternative parents and children in order to know what to do. When the link fails, you basically 100 send an ICMP message through 110 to the root in order to do the same notification, basically. Okay, so we need to exchange some more state, but we still can walk around the link failure. Okay, and when we go down, the root knows that something is wrong, and it can decide to do some kind of source routing in order to send the packet to the right destination, looking to forwarding through an alternative path. In that case, however, you can have some overhead because you need to embed the path, the alternative path, which is not the natural path in your packet. Okay. For the sake of time, I will skip the flowcharts, but these are in the document, pretty easy. So if we want to compare a little bit to two classes, the multiple addresses, single address, the amount of state that we see in the root, in the multiple addresses, is low because you just have a redirect rule. The single address, the root needs to know that your full topology in order when we go downlink, we need to know which path to build, okay? In the forwarder nodes, the state is in both cases relatively low. Some rules can be there or neighborhood. And the robustness, if you have multiple failures, the multiple addresses, there is no clear synchronization, could be weaker in that case. But in the single address case, since the root has a global vision, can do smarter choices. But again, if you have a lot of failures, then you have a bigger global. And that's it. I gained a little bit of time. If you have any question now or later on the mailing list, please send any feedback.
Okay, any questions from the room or remotely? Okay, so
Thank you very much.
Thank you for the presentation. So the next presenter will be me, actually. So Shweta, if you can share the presentation. Okay, thank you. So hello again. I'm going to present the last update of the draft entitled Transmission of SHIC compress packets over IEEE 802.15.4 networks. My co-author is Ana Minaburo from Aclio. Next, please. So first of all, a reminder for the motivation of this draft. As this working group knows well, RFC 6282 has been the basis for header compression in 6LoWPAN and also in 6LoW. With this RFC, it's possible to compress a 48-byte IPv6 UDP header down to just 7 bytes, in the best case with global addresses. However, there is a more recent specification called SHIC, which is the main product of the LP1 working group, which is able to compress even further the same header down to just, for example, 1 byte. That's because SHIC uses static context based on a priori knowledge of the header field values of the packets that will be transmitted. Then if we take into consideration also an application layer protocol like CoAP, there is no 6LoWPAN style header compression defined for CoAP, but there is a way to compress CoAP headers with SHIC. So here we are considering two examples, two cases of CoAP headers. One, which is A, means no header options, which means a header size of 4 bytes. Case B corresponds to the example in table 6 in RFC 8824, where the CoAP header size is 16 bytes. So in both cases, with SHIC, it's possible to compress those two headers down to just, for example, 1 byte, which leads to a total improvement, which is quite significant. If we consider the joint IPv6 UDP CoAP header size with 6LoWPAN, we can compress those down to 11 or 23 bytes, depending on the two cases. But with SHIC, it's possible to compress them down to just a couple of bytes in both cases. So, for example, this represents a battery lifetime improvement for battery-operated devices over 15.4 by a factor which, in theory, could be even greater than 2. Although a disclaimer here is that the actual improvement will be lower depending on different parameters and settings, like the device hardware features, such as sleep current consumption, different settings at the MAC layer, adaptation layer, application layer, payload size, network topology, and so on. Next, please. So just to provide a few more details on this, this figure shows the maximum battery lifetime improvement factor as a function of the CoAP payload size in the horizontal axis. And here we are assuming some things like short MAC addresses, intrapan communication, and a sensor that is battery operated and periodically transmitting a message, for example, containing sensor readings over 15.4. And we are considering also stat topology and mesh under. So we may add route over in future updates of this figure. And as you can see, there is some improvement factor, which is reasonably significant, and it increases as the CoAP payload size decreases. And anyway, this is theoretical results, so the actual improvement will be somewhat lower. Next, please. So on the status of this document, there was some previous document, a precursor to this one, which was presented already in IETF 110. Then this document I'm presenting tries to provide all the details required to enable the transmission of SHIC compressed packets over 15.4 networks. And the previous first 4 versions of the draft have been presented in the last 4 IETF meetings. And today I'm presenting revisions 04 and 05, where the main one is actually 04, which aim to incorporate the feedback from the last IETF and also from discussion on the mailing lists of the 6LoW and LP1 working groups. Next, please. So let's see the updates in the draft. First, there are some changes in the organization of some of the content in the document. Previously, there was section 6 entitled Multi-Hop Communication, which now has increased, and now it's located in section 3, Architecture. Also, we have modified the change of the 2 previous subsections in the architecture part in order to provide a better introduction to the multi-hop communication topics. Then in this multi-hop part, we describe at the moment 3 different possible approaches to transmit a SHIC compressed packet over a 15.4 multi-hop path. And then section 4 has been extended as well, because now we provide the frame formats that correspond to these 3 different approaches. And finally, there used to be subsection 5.3 in section 5 about header compression examples. However, well, the section still, by the way, needs to be developed. And now, for the moment, we are moving it to an appendix, which seems to be a better place, probably. Next, please. So on section 3.3 on multi-hop communication, these are the three approaches by which a SHIC compressed packet may be transmitted through a multi-hop path in a 15.4 network. Now, the first one, we are calling it straightforward route over approach. In this case, all nodes must store all the rules in use in the network for compression decompression. That's because maybe a node could be a node in the middle, an intermediate node, which might need to decompress and compress again. However, while this is good in terms of header overhead, this is probably more suitable rather for small stable networks or perhaps without nodes without memory issues. Then there's another approach, perhaps for larger networks, which we are calling now tunnel ripple-based route over approach, where an endpoint must only store the rules for the communications it's involved in as an endpoint. So later we'll see the details for this one, which is the details have been added in these last updates. And there is also the mesh under approach by which an endpoint must only store the rules for the communications it is involved in as an endpoint as well. Next, please. So on the tunnel ripple-based route over approach, here the assumption is that we are using ripple non-storing mode. And the overview would be as follows. Packets sent by a 6LN are tunneled upward to the root. And if the final destination is another 6LN in the same ripple domain, then the packets are tunneled downward from the root. So then we have RFC 9008, which describes how a packet would be transmitted from a 6LN to another node, which could be another 6LN or the root in the same ripple domain or an external node. So according to this RFC, for downward traffic, there is IPv6 in IPv6 tunnel, except when the root itself is the packet source. And when there's the tunnel, it terminates at the 6LN if this is a routing aware leaf, or at the last 6LR if the 6LN is a routing and aware node. And then for upward traffic, there is IPv6 in IPv6 encapsulation performed by the, or initiated by the 6LR if the 6LN is a routing and aware node. And by the way, there is no tunnel if the destination is the root. And then there is IPv6 in IPv6 encapsulation only optionally from the 6LN if this node is a routing aware leaf. So next, please. So we understand that we need to have a tunnel for upward traffic. So we understand that this document would need to update RFC 9008 by stating that when a 6LN transmits a SHIC compressed IPv6 packet, it must be tunneled by means of IPv6 and IPv6 up to the root, regardless of the final destination. And then there's another point, which is a to-do at the moment, which is address the case of the 6LN being a routing and aware leaf, because in that case, it is the 6LR, the first 6LR, the one who initiates the tunnel, or the last 6LR, the one who terminates the tunnel. So we need to address this case. And then for the sake of efficiency, the idea is using RFC 8138 to compress the different routing artifacts, the IPv6 and IPv6 headers, the ripple option, and the source routing header. Next, please. So these are the frame formats that would be used. The first one is the one that we had seen previously in previous versions of the draft. This one can be used for single hop communication or in the straightforward route over approach. So here, this format starts with the SHIC dispatch, some bit pattern in page 0 in this case, that signals that what comes next is a SHIC compressed packet. And then what's new is the formats for the tunnel ripple-based route over approach, where we can see the main format for downward communication, which is inspired by RFC 8138, where we start with the page switch, which indicates that we are in the dispatch type page 1. Then there's the 6LO-RH headers for the source routing header, ripple packet information, IP and IP encapsulation, and then SHIC dispatch telling that what comes next is a SHIC compressed packet but in this case, the dispatch would be in page 1. So as you can see, it would be the same bit pattern, but in this case, also in page 1. By the way, this bit pattern seems to be not allocated at the moment. Next, please. So for upward transmission, the format is similar. However, in this case, we don't need the source routing header. And for mesh under, the idea is that the formats would be the same as those in RFC 4944. However, the compress header in this case of the IPv6 packet would be, the header compression would be made by means of SHIC. Next, please. So there are other few updates. In section 5, which is about SHIC compression of IPv6 UDP COAP headers, now we've added that each rule defines the set of protocols whose headers are being compressed or decompressed. For example, in some deployment, one could decide to assign rule IDs 1 to 3, for example, to compress the IPv6 header only, rule IDs 4 to 7 to compress IPv6 UDP, and rule IDs 8 to 15 to compress IPv6 UDP COAP. And other than that, we also have updated the IANA considerations because, as mentioned before, we need to request the allocation of a dispatch type for SHIC, but not only in page 0, also in page 1. And by the way, it seems like, especially if we need to update perhaps a role RFC, well, we may need to keep the role working group in the loop, perhaps more formally, even if some of the participants are actually also 6LO participants. Okay, so next, please. Yeah, so the document is getting more and more complete. Of course, it's not yet finished, but the authors would like to ask if the document would be ready at this point for working group adoption. So, Shweta.
Hey, thanks, Carlos. So, can we get a sense from the room on how many people have read it and would be interested in reviewing and continuing to work on this as a work group document? Should we do a show of hands or hum?
Yeah, so I'm hearing suggestions to, if you maybe want to run the poll through Miteco, maybe?
Okay.
Okay, so Shweta, if you
Yeah,
want to make
so
any
we have
comments?
about 16 people who raised hands in support. No one opposed it. So we'll take it on the mailer and start our group adoption call.
Okay, thank you.
Thank you.
So, any comments or questions? So we are, well, we have 1 minute left. There is, if you recall, there is this if time permits presentation. So perhaps if it's possible to do it maybe in 5 minutes quickly. Hangxi, are you present? Yeah.
Okay. Hello, everyone. My name is Han Shi, and I'm going to present an IPComp extension. Next slide, please. Yeah, the background is really simple. The IPComp is compressed IP payload, and the compressed payload is prepared with the IPComp header, contains the compression parameter index to indicate the compression algorithm, and is located in the IPsec, this IANA registry. Next slide, please. Next slide.
Next.
Yeah, and the problem with the IPComp, the first problem is that it's incompatible with network function, which requires the layer 4 information, because the layer 4 information is already compressed. For example, NAT file or ACL may need to access this compressed information, so they cannot deploy between the IPComp nodes. Next slide, please. So the first extension is about do not compress this source port and destination port information. Basically, there are two options to do that. We can change the flags to add 1-bit indication, or we can change the CPI to duplicate each compression algorithm code point. Next slide, please. And the second problem is that out of order processing. Basically, it's because the IPComp may produce longer payload. The compression is not effective, for example. And the RFC says that if compression is not effective, you just send the uncompressed without any IPComp header. But in the decompression side, the packet with the IPComp header will go through the decompression coprocessor first. But if a packet is without IPComp header, it will be forward directly. So it's different process. It's called out of order. Next. So the second extension is about we add the IPComp header regardless of if the payload is sent uncompressed or not. We can just add a new CPI value for the uncompressed packet. Next slide, please. Yeah, that's all. Basically, we think 6LO also have some kind of compression on the header. So we think we can ask for a suggestion about this kind of design. Anyone have comments?
So at the moment, there are no comments in the room or remotely. Perhaps it might be good if you send a pointer to your document to the 6LO mailing list.
Okay.
Just in case people have time to read it. Also, people who are not present in the meeting.
Okay. Sound good?
Yeah.
Oh, yeah. Okay.
Yeah. So did you hear the comment?
Yeah.
Okay. Okay. So yeah.
Okay. Thank you.
Okay. So the session ends here. Thank you, everyone, for the participation, and hope to see you in Yokohama. Thank you as well. Yeah. Thank you.